Hi, welcome back to the lab, and today it's another video where we look at electronic components. Remember earlier we had looked at resistors and capacitors. So today we are going to look at this component, which is a fuse. So a fuse is one of those components in electronics that is very simple to understand, and yet it's a very important key component. So for starters, maybe we can define a fuse. So a fuse, we can say a fuse in electrical and electronics is an electrical safety device or component that operates to provide overcurrent protection in an electrical circuit. So the most important part of a fuse is a metal wire or a strip that melts when too much current flows through it. So if you look at this one, you can see a tiny wire inside. So that is the most important piece in a fuse. So a fuse is usually connected in series with the load or whatever system or part of a circuit you need to protect. So here what we are saying is that you are going to have your supply of power here. So this is your supply or source. Then you are going to have a fuse here, which will be connected in series with your load or whatever part of the section, whatever section of a circuit you need to protect. So this is our fuse. You connect it in series with load. What if you connect a fuse in parallel with the load? So if you happen to connect your fuse at this point, you will be short-circuiting the circuit, and your load will not be getting any power, and most likely your fuse will blow up. So a fuse will always be connected in series with your load. So now, how do you identify fuses? You can identify fuses by the following symbols. So the first one, you can have a symbol drawn like this, maybe on paper or printed media. So if you see a symbol like this, most probably that is a fuse. It can also be drawn like this. That also denotes a fuse. You can also have the most common, the most usual sign of a fuse. Also, this side might not be enclosed inside a rectangle. It can be drawn like that. In printed circuit boards, you might find a fuse labeled F1. So F denoting a fuse. So we can look at an example here. So if you look at this, this is a home theater power supply. You can see here we have the sign, this one, and also we have the letter F, F901, denoting this is a fuse. So that's how you identify a fuse. Now if we look at a more a complex circuit like this, we can see F1 here, denoting this is a fuse. This little component is a fuse. You can also see another sign of F2 here, but this one is not present. That's how you identify a fuse in a circuit, by the marking letter F. So the next bit we need to look at in fuse is the fuse ratings. So fuses are usually rated in voltage and current, but the most important thing to know, or the most important rating of a fuse to check, is the ampere rating, so the current rating. So the current rating of a fuse gives the maximum amount of current a fuse can handle before blowing up. So if you look at a fuse like this is 13 amperes, and it's rated at a voltage of 250 volts. So if you want to use this fuse, any current above 13 amperes will make this fuse to blow up. You might also have a fuse rated in only current, like this one. We don't have any voltage written on it. So the most significant rating you need to consider is the ampere rating. So that's how fuses are rated. And the next thing we need to know in fuses is how to select a fuse for any system. So assuming you have a system that you want to protect in way of using a fuse, so you will need to consider two things: the voltage you want to apply to this system, and the current you want to apply to this system. Also, you may want to consider the power consumption of this system. In most cases, you might find that let's say it's a device. In this case, let's use an audio amplifier. So you might find that an audio amplifier is rated in only power. So let's say you will have an audio amplifier rated to operate at 10 volts and an output of 100 watts. 10 volts and an output of 100 watts. So using that, you'll need to calculate the amount of current this audio amplifier will be drawing from your source. So in our case, as we have said, assuming we have a system that gives out 100 watts of power, and this system is applied with 10 volts. So to get the amperes rating or the current ratings, you need to divide the power by the volts. So this system will consume 10 amperes of current. Now here is the catch: if we use a fuse that is exactly 10 amperes in ratings for this system, it might work for a little bit, but we face another problem of the fuse blowing up unintentionally. So the thing is, there is no system that is 100% efficient. So some of the power here will be lost due to heat, and it's because of this reason you will find that in order for us to get a clean 100 watts the output, this system will have to draw more power from the source due to that inefficiency. So now let's now select a fuse for our system. There are two factors we need to consider here. One is that there is no system that is 100% efficient, and two, there might be surges and spikes in our power and our power supply. So we can't use a fuse that is exactly 10 amperes. We need to consider the efficiency of the system and also the fact that we might have some surges. So we can only use fuse rated at 10 amperes in an ideal situation, but in real life we don't get that kind of a situation. So what we do here, we consider the efficiency of this system to be 50 to 85%. So that means that in order for us to choose a proper fuse, we need to consider that efficiency, and our fuse in this case should be for 50% efficiency. We can do 150 over 100. You multiply by the ideal current. So what you get here is 15 ampere. So that is on the higher side. Also, you can do 125% over 100. This is for the 85% efficiency. So you get 12.5 amperes. So a proper fuse for our system should be between 12.5 amperes to 15 amperes. So that's how you select a fuse. So the next bit is we can maybe look at some types of fuses. We have types of fuses, different types of fuses, and the most common one is this. This is known as the cartridge fuse. It has a transparent envelope enclosing the fuse wire. So you can see the fuse wire inside. They also come in this form, but this one is not transparent, so you can't see the fuse wire. So that's the first type. So the second type is the automotive fuses, or the blade fuses, like this one. So this is it takes the form of a blade, and like this one is rated at 7.5 amperes. So these automotive fuses are color coded, and each color stands for a particular current ratings. So the other one is what we call the resettable fuses. So the resettable fuses are kind of interesting because they have a carbon black compound mixed with the organic compound, and the compound is conductive due to the carbon black. How these fuses work is that whenever a large amount of current flows through this compound, it generates heat, and whenever this compound starts heating up, it will expand, and these carbon black particles will start moving far away from each other, and therefore making this compound less conductive, to a point where it does not conduct electricity for this case. So once the temperature reduces, this compound will contract, and the carbon black particles will move closer to each other, hence regaining the conductivity. This is the reason why these fuses are known as resettable fuses, because they reset the conductivity once the temperature reduces. You don't need to replace this kind of fuses. The name suggests they will get back to the normal operations. So you can go and do your research about fuses. You can go and look at more types of fuses, and make sure you learn something new. So but for this video, I think we are done. See you in the next video.